Hey guys, so this is going to be a fairly long video, I think. We've got three distinct topics. We have just sort of introducing the Cartesian coordinate system and graphing ordered pair. We're going to have graphing lines, graphing using an equation. Again, kind of plugging in and using ordered pair, which isn't the best way to graph a line, but it's sort of how we get it introduced. We're going to get some better techniques later. And then the third thing will be graphing using intercepts, which that one's actually pretty good for one situation at least, standard form versus slope intercept, and I'll talk about that when I get there. Okay, so in this first example, we're just introduced to the Cartesian coordinate system, sometimes called a rectangular coordinate system, and then these ordered pair. So what an ordered pair is where you have a pair of numbers and they're, in an order, because these clever names for things in math. It always goes XY, and this is our X and this is our Y axis. And these axes can actually be named different things, but typically it's going to be X and Y. If you get into physics or some application problems, that can change up, but that's kind of our typical. And X goes, positive the way it always has, and negative, to the left. And then for the Y axis, it's positive up and negative down. So this 4, 2, what this is basically directions on how to get to this point. It's saying we're going to go 4 over on X, so starting from right here, which is 0, 0, and this is called the origin. We're going to go 4 on X, so we'd count over 1, 2, 3, 4, and then up 2, 1, 2. And so that point right there, that would be A. B here would be 1, negative 3. So X is 1, so we're going to go right 1, but then Y is negative 3, so down 3. And that will be B. C, 0, 0, that's the origin. That's what I was talking about right here. D, 0, negative 2. So our X is 0, so we're not going left or right, we're just staying right there. And then our Y is at negative 2. That'll be right there. And then E, X is negative 2 and Y is negative 4. Right there. And then this one is just going the other way, so given the point, read the coordinates and write down the ordered pair. Careful when you're doing these on the computer. They generally, you'll see it a couple of ways. If it's just an answer box like that, you're going to need to type the parentheses and, whatever the number is, 4, 2 or something with that comma in there. Sometimes they'll have it where they have like this, and then you just type the 4 and the 2 straight into the box. But careful if it's an empty box like that you get those parentheses. Otherwise, it's not an ordered pair, it's a list, and that's a different thing. So that's a little bit important. So for A here, we're going right 2, so that means my X coordinate is 2, and we're going up 1, 2, 3, 4. So that would be at 2, 4. For B, let's see, we're going 1, 2, 3, 4, 5 to the left. So that would be a negative 5. And up 1, 2, 3. C, we're going left 1, 2, so that's a negative 2. And we didn't go up or down, so that means we just stay 0 on the Y. D, let's see, 1, 2, 3, 4, 5, so positive 5, and then down 2, so that'll be a negative 2. And then E, we didn't go left or right, so that's going to be X is 0. So notice when we're on the x-axis, the y is 0, and when we're on the y-axis, the x is 0. Those are going to be intercepts a little bit later. And then this is 1, 2, 3, 4, 5, so negative 5. Let's see, so this one says, give the points, or actually to say given, sorry, I think I got that in the notes, but given the points negative 4, negative 1, and 2, negative 4, draw a straight line that passes through them and answer the question below. Do the following points fall on the line. So we're just going to take these two right here. So we're going to go negative 4 on X and negative 1. And then X is 2 and Y is negative 4. So it's going to be like this. And so if I kind of look at it, I can kind of see it looks like it's going over 2, down 1, just to kind of extend my line. These are a little hard to draw. Okay, so I got my line drawn. And then we're going to come back and see if these points fall on this line. So if I take this first one, negative 6, 0, so I go over 1, 2, 3, 4, 5, 6, and 0, and yep, that one does look like it falls on the line. When X is negative 2, Y would be 2, so that's a no, that's not on the line. And then when x is 4, y is negative 5. 1, 2, 3, 4, 5. Yep. And so that one is on the line. So this one's kind of the reverse to the last one. They gave us the line, and now they're giving us this table, and then asking us to find the corresponding points. So this little XY table, sometimes it's called a T table. It's just another way of saying negative 3 and then some value for y. So a lot of times we'll organize our ordered pair in a T table. So here, when x is negative 3, I can just go 1, 2, 3. So it looks like the y would be negative 2 in that case. When x is 0, so that means we're not going to go left to right, looks like y is 1. When y is 0, so when y is 0, we're not up or down, so that's right here. Then the x coordinate for that would be negative 1. X is 3, so we go 1, 2, 3 on x. We go 1, 2, 3, 4, it looks like. So when x is 3, the y for that would be 4. And then lastly, what x would make the y 5? So I can come up 1, 2, 3, 4. Oops, 2, 4, 5. So that's right here, and then trace it back down, and it looks like that's happening at 4. Okay, so this next set of problems is graphing linear equations, filling in a table, or using ordered pair. This isn't really the best way to graph linear equations. When we get a little farther in the chapter, we're going to get slopes and intercepts, and that's going to be better. That said, this is useful for when you don't know what something's going to look like, but as we get smarter ways to do this, we're going to want to this shouldn't be our go-to. But it's a starting place, so that's kind of how we're going to look at it. So for some of the problems on the homework, they're going to give you the x values, and for some of them, these will just be blank, and then you're just picking your own x values, because it doesn't really matter what you pick, just something on the graph, don't pick 10,000, pick easy numbers. And we're just going to pick some x's and plug them in, and then see what y comes out. So for this one, if I let x equal negative 1 as it's asking me, I go, negative 1 times negative 2, and I get 2. If I let x equal 0, 0 times anything is just 0. If I let x equal 1, I'd have negative 2 times 1, and that would be negative 2. And so I just generated, a set of ordered pair that's going to define this line. I really only need 2 points to graph a line. They're going to ask for 3, because that third one is the check. Because then if you get one of them wrong and they end up not in a line, then that's how you know one of them's wrong. But with that, let me get this part here and there, and so there's our line. When you graph this on the computer, and this is super important because it will totally piss you off if you miss this, because it's really frustrating because they don't graph right. So it's going to ask for 3 points when you're filling it in. When you go to graph it on the computer, only use 2 points. You'll see me graph all 3 on here just because I'm trying to get a straight line going on paper, and I'm not that good at drawing straight lines. But on the computer, only use 2 of the points. If you use the third one, it marks you off a 10th point or something, and you can't figure out what's going on. So it's just 2 points. So with that, now this next equation, I'll go ahead and throw the negative 3 in. And this is a good example if you have to pick points yourself, which is normally the case. And they're kind of starting you off with some friendly ones where they give you the x's. But when you're picking the points, I could pick 1, toss it in here, but now I have to try to graph that fraction, so that's not that awesome. So if you got a fraction in front of the x, you want to pick something the denominator goes into, like in this case 3, because then when you go to evaluate, so negative and negative is going to make it positive, and you cancel negative and negative, so it's going to be 5. So it gets you a nice, easy point to graph. So if this had been 5/4, I'd have negative 4, 0, and 4. That'd be my picks. Whatever the denominator is, that's the one to put in, because you get the nice, easy cancel. If x is 0, then 0 times who cares is still going to be 0. And then if it's 3, hopefully you can see the 3's. If I put a 3 here, they just cancel. I'm left with the negative 5. So that's kind of the trick to graphing the ones with a fraction. So let's see, when x is negative 3, y is 5, so that's up here, 0, 0. And again, on the computer, that's all you need. I'm going to get this last point just because I try to draw a straight line. There we go. And that'd be it. A few more examples of the same thing. So here I'm going to have a negative 1 in there, so let me just kind of show some work. So I'd go negative 3 times negative 1 minus 1. So that's going to be a positive 3 minus 1, or y equals 2. This one, let's see, when x is 0, that one's actually pretty easy because it knocks out that whole term. So it's just going to be the negative 1 on the end. And then if x is 1, I get negative 3 times 1 minus 1. And so that's going to be minus 3 minus 1 equals minus 4. So graphing, I get negative 1 right there. I'm going to get when x is negative 1, y is 2. And when x is 1, y is negative 4. It's right there. Here, so you can see the denominator is 4, so they're giving you 4s. That's the trick to doing that. And again, we're going to get a better way to graph this in like not too long, like just a couple of sections. But for now, here it goes. So y equals 3/4 negative 4 plus 2. So there the 4's will cancel. It's a negative and a positive, so that means this will be a negative 3 plus 2, or negative 1. X is 0, so again that knocks out that whole term, and we're just going to get the 2 on the end. And for 4, we'd have 3/4 of 4 plus 2. So 4's cancel, and I'm left with 3 plus 2, and that will be 5. So when x is negative 4, 1, 2, 3, 4, y is negative 1. When x is 0, y is 2, and then when x is 4, y is 1, 2, 3, 4, 5. And then draw a kind of straight line, and that would be that one. So these next two are kind of the exceptions. So they look a little funny. Y equals 2. And what that means is pretty much y equals 2. It doesn't really matter what x is. Y just equals 2. So we can just throw 2's in there everywhere. And so if I graph that, when x is negative 1, y is 2. When x is 0, y is 2. And when x is 1, lo and behold, y is pretty much still 2. And so what you get is a horizontal line through 2. And so this just says it doesn't matter what x is, the y's are always 2. Something about these is you're going to see that y equals, and you're going to want to draw a vertical line because you think, y's go this way, which they do, but this says y is constant, it's always 2, and so it's the x that's varying and the y that's staying the same. So it's kind of backwards intuitive. So this is its kind of opposite, which is x is negative 3, so that just means it doesn't matter what y is, x is always going to be negative 3. So when x is negative 3, 1, 2, 3, y could be 0. When x is negative 3, y could be 1, negative 3 could be 2. So you can see x equals gets us a vertical line. So again, those two are kind of counter intuitive, but that is what they do. So that wraps up the plotting by kind of plugging into the equation. Okay, this next one's about x and y intercepts. And so x and y intercepts are the places where the graph is crossing the axes. So you kind of think of this as the graph, that would be the y-intercept, and down here would be the x-intercept. And so something about that is if you're looking for an x-intercept, the y is always going to be 0 because you're going to be neither above nor below the axis. Likewise, if you're looking for a y-intercept, then the x is going to be 0 because you're neither left nor right. So to find x and y intercepts, pretty much all you do is plug in 0 and solve for x, and then plug in 0 for x and solve for y. And that is intercepts. So let's see how that looks. With this, if I plug in the 0 here, oops, let me write that better, 3x minus 2 times 0 equals 6. So that whole chunk drops out, and I get 3x equals 6. So what I usually when I'm doing these is I just say, okay, if y is 0, I just kind of think of covering that piece right there up, and then I have 3x equals 6, and I can see pretty easily that x has got to be 2. And you get that writing it out also. But you can do a lot of these without having to actually do this step over here. So like here I'd go, so x is 0, so then that just leaves me the negative 2y equals 6, and then dividing that, y equals negative 3. So then that gets me my 2 points, and then I can use those to graph my line. So here when x is 2, y is 0, and when x is 0, y is negative 3. And so for the equations that are in this form, and what this is called standard form, and it's where it's like, well, the form looks like this: ax plus by equals c, but it's where the x's and the y's are on the same side. So when you're in standard form, the intercepts are pretty much really often going to be the easiest way to graph it, actually. So this is actually a pretty good technique for this style problem. So having said that, that means it's probably not the best technique for the next problem, which is the case. The y-intercept's great for this. If x is 0, that all drops out, and that number on the end there is always going to be the y-intercept. And as we get a little farther in the chapter, we'll see that this is y equals mx plus b, and that b is the y-intercept. So that's going to be negative 4. But so then finding the x-intercept on this one isn't as great. It's a little bit of work. So like I said, once we get some more techniques and we learn about slope, this is not how I'd graph this one. But for right now, if we're asked to find the intercepts, this is what we would do. Here I'm going to add my 4 over. And that's going to get me 4 equals 2/3 x. And then since I got a 2/3 there, I'm going to multiply both sides by 3/2. And that's going to go 12 over 2, so that would be 6 equals x. And then graphing, let's see. So y-intercept 0, negative 4, and x-intercept at 6. So it should kind of look like that. So this next one's a little bit special in that when I go to find the intercept, if I let, x equals 0, then y is 0. So you can see both intercepts are 0, 0. So I'm going to need to get one more point. Let me rewrite that down here since I just scribbled on it. 3x. So I'm going to need to get one more point in order to finish graphing my line. So then I can just kind of do the little t-table thing and say when x is 1, y would be negative 3, and then that gets me my second point. And my line would kind of look like that. So in a lecture class, the next, I think, 6 or so for the rest of the video are all the ones I would have you guys try in class. It starts off with an exception, x equals negative 1, so we just looked at that. And remember, what this really means is it doesn't matter what y is, x stays negative 1, so y could be 0, y could be 1, y could be anything. And you can also just remember it's a vertical line. So if you remember it's a vertical line, cool, just draw it like that. But if you get mixed up and you're trying to like, oh, was it this one or this one? You can always make that little silly table and just do, negative 1, 0, negative 1, 1, and that'll help you get that orientated correctly. And so then the x-intercept has to be negative 1, right? Because that's all it does is it's there and it's negative 1. So the next one is its counterpart. So this is the y equals 4. So if you remember, that's a horizontal line through 4. Great, go ahead and just draw that. And if not, if you get a little mixed up on which way does it go, make a little table, because y has just got to be 4. And if you grab yourself a couple points, x is 0, y is 4, x is 1, y is 4, it'll help you get it going the right way. So, of course, no x-intercept for this, and the y-intercept will be 4. Next example, this one's in standard form again, so this is really not too bad. If I let y equals 0, you can see that whole y term is going to drop out, and I'm going to be left with, I'll go ahead and show it right here. You can see this just drops, and then you're just left with negative x equals 3, and carefully get that sign scooted over, and so that's going to make it x equals negative 3. And then if the y is 0, x is 0, then I'm left with 3y equals 3, and so then y equals 1. So you can see that's a pretty easy way to get that one graphed when the x and y are on the same side. So x is negative 3, y is 0, and when x is 0, y is 1. So it should be about like that. This is the other form, so this is slope-intercept form. So here when y is 0, we have to do a little math. And then I'll go ahead and solve for the x. I'm scooting my 2 over. Negative 2 equals negative 3x. And then I can divide out the negative 3. Those cancel, and the negative from negative would make positive. And then the y-intercept, that's the easy one. When x is 0, y is 2. So that would be right here. And then 2/3 would be right about there. I don't think they're going to make you graph ones on the, in between the points like that, but there's one. Oops, sorry, I just realized I graphed this one wrong, so this should have been at 2. Glad I caught that. So then the 2/3 was good, so this should be going that way. Sorry about that. This one, so this is that kind of game where we go, okay, we plug in the 0 for x, and we get, 0 for y. So we're just going to get 0, 0 twice, and then that's where it's beneficial to pick, that next point. So I'm going to pick, I could pick anything, right? I could pick 1, but then I'd have to graph a fraction. So I'm going to be smarter than the fraction, and I'm going to pick 3. Because then I have y equals 2/3 of 3. My 3's drop out. I get a nice easy -2 to graph. So here we are at 0, 0, and then when x is 3, y is -2, and that gets us something about like that.